Welcome back to the next section of Chapter 5, and we're going to be talking about pressure today. And so first we got to define what is pressure. Well, all pressure is a force exerted over an area. And so there are common units that we use for pressure. Those are atmospheres, abbreviated as ATM. We have kilopascals, which is little k, big P, little a, and then millimeters of mercury. And I'm apologizing again if you can hear Mac in the background with his toy. He tends to get loud when I'm lecturing. Funny how that works. And so on these units, there are some conversions that you need to know. And so for every 1 ATM, and this is 1 with 3 zeros, that is equal to 101.3 kPa, which I always loved because I never forgot because of KDWB. Mac. And then that is equal to 760 millimeters of mercury. So these are kind of the conversions you need to know between the units. And so let's practice doing some conversions here. So if I have 2.35 ATM and I want it in kilopascals, so I am looking at this part of our relationship here. And so I always start with what I know, 2.35 ATM. And so I want ATM to, oh, that's an awful line. I want ATM to cancel. So I will be putting the 1 ATM and then 101.3 kPa here. And so from there, you should get 238 kilopascals. Now let's go from kilopascals to ATM. 123.4 kPa times its conversion factor of, now we're putting 101.3 kPa on the bottom and 1 ATM on top. That gives us 1.218 ATM. And so there are different types of pressure. We're going to talk specifically about vapor pressure. And so, go figure, this is the pressure exerted by a liquid's vapor. That's sealed in a container, which has come to vapor-liquid equilibrium. And this is at a given temperature. One thing to note is that vapor pressure does not depend on the mass or volume of the liquid. And so if I say the stronger the IMF, do you think it's going to have higher or lower vapor pressure? So if the intermolecular forces and those molecules want to stay together more, do you think it's going to have higher or lower pressure? It's going to have lower. And so when you have high vapor pressure, you're going to have quick evaporation. It's going to be volatile liquids. And so let's talk about boiling point. And so boiling point actually has to do with a liquid's vapor pressure. So it's when a liquid's vapor pressure equals the pressure exerted on the liquid by outside sources. This is when it starts to boil. And we have this new term that we define as normal boiling point. And so this is just the boiling point of a liquid at 1 atm, or 1 atmospheric pressure. And so you guys should have recall this table. We talked about it briefly. And so we're going to remember how to read this because this is important for this unit. One moment. Matt, you're being loud. Should we on your bed, please? Thank you. Okay, sorry about that. So, oh my goodness. What is the vapor pressure of ethanol at 40 degrees C? So, you're on the temperature scale. You notice that each one of these lines is by 5. So 25, 30, 35, 40. Well, what is the temperature here? And so we'd estimate it if these go up by 10, somewhere between 10 and 20. So a bit closer to 20. Let's just say 17 degrees. Or sorry, 17 kPa, as that's our units. What's the boiling point of water at 30 kPa? So here we go up 10, 20, 30, follow it over till we hit water's vapor pressure line, follow down to see the temperature, and this looks like it's at about 70 degrees Celsius. And then what's the normal boiling point of propanone? Well, here they already marked off our 101.3 kPa line, because remember, if it's at 1 atm, that's the same thing as at 101.3 kPa. So this is normal boiling point. So if we follow this over to propanone and follow that down, that is at about 55 degrees Celsius. And so we also need to brush up on phase diagrams. And so I am going to stop this video because my dog is ridiculous, and we'll pick back up in a second.